I'm interested in all the ways animals impact and are impacted by the ecosystems they inhabit. Animals interact with ecosystems in all different sorts of ways, but one of the ways is when they consume and then disperse nutrients across ecosystems. And this really impacts the heterogeneity of resources available on the landscape scale. For this work specifically, we were interested in white-tailed deer because they're very abundant in Northeast forests. And we were interested in whether or not when they calve, they deposit a lot of nutrients that then can accelerate nutrient cycles and create nutrient hotspots on the landscape. So we went out to Yale Myers Forest and we simulated calving spots throughout the forest. And we ultimately found that calving was creating these microsites of nutrient hotspots. But really interestingly, we found that ecosystems ultimately could modulate that impact, and specifically the plant fungal dynamics that were underneath the hotspots. And we found that this ecosystem context was something we really should be thinking about when we're studying the ways in which animals are interacting with nutrient cycles. The field of zoogeochemistry, which is this study of how animals interact with nutrient cycles, is really in its infancy. And steps forward to accelerate this field is first understanding and identifying the mechanisms in which animals are interacting with nutrient cycles, and then understanding those context dependencies that ultimately modulate those interactions. And our work was really cool because it did both. We identified this novel interaction, this input into nutrient cycles from calving, and then ultimately also looked at some of the context dependencies, specifically plant fungal associations, and how that ultimately creates these context dependencies we should be thinking about. This work is really interdisciplinary. It combines animal ecology, community ecology, ecosystem ecology, and plant fungal ecology. And so I really wanted to make sure we were representing how we brought all those fields together to create this interdisciplinary work. And because it was super interdisciplinary, it offered this unique opportunity for me not only to work with a bunch of YSE faculty, but also with other YSE students and students at Yale broadly. And it's really fun to collaborate with people across disciplines, and so I wanted to bring some of that fun and that joy of doing collaborative science to the presentation as well. What's special about the Bormann Prize is the legacy that it represents. Professor Bormann not only did really interdisciplinary work, he did impactful work. And that's the sort of work I want to do. I want to do work that not only brings disciplines together to help us better understand conservation and ecology, but makes us do better conservation and ecology. I want to do work that matters, and this prize is a huge step and a huge motivation to help me continue doing that work. I think there's just so much more we can learn about how animals are interacting with ecosystems. I absolutely plan to continue this research.
I did something, but most of what goes on here is what you did.
I had no idea that my advisor was nominating me for this prize, so when I got the notification, I was so excited. This is the prize for PhD students at the Yale School of the Environment, so it was really exciting and humbling. And also a lot of researchers that I really admire have won this prize in the past, so it's really cool to be following in their footsteps. I'd like to say thank you to the Bormann family for continuing to support research at YSE and inspire young researchers to do work that's at the bounds of their own discipline, and to the YSE faculty for recognizing me for this prize. It's really an honor, and I'm very humbled.